Hello and welcome to part 2 of Data Modeling with Class Models. The course is part of the Necessitas Business Analysis Enablement Program, delivering training in core business analysis skills. It will show you how to produce class models to specify information requirements in a graphical format. The course has been designed for business analysts and requirements engineers. It will also be of interest to anybody with an interest in the development of requirements for business systems. This would include data analysts, developers, testers, and project managers. So what are the objectives of the course? The course will use meaningful and practical examples to explain and demonstrate the notation used when producing class models and show you how to develop them for yourself. Having completed the course, you will be able to produce class models for your own projects or read the models produced by others. So what will we be covering on the course? The course is made up of 5 parts, each part covering a key aspect of class modeling. As we progress through the course, we will develop an example class model to illustrate the points covered. Part 1 of the course provided an overview into what class models are, what they look like and why we use them, and we introduced the key components of a class. In part 1 we made a start on our example class model, creating a model with a few example classes. In this part 2 of the course, we will add associations and business rules to our example model. In part 3, we will look at the importance of keys and develop the model further with primary keys, foreign keys, and derived attributes. In part 4, we will complete the model by adding generalization, aggregation, and composition, and consider how to capture historical data. In part 5, the final part of our course, we turn our attention to data definitions, which are used to provide more detailed information on the classes, business rules, and attributes represented in the model. So let's get started with a recap of part 1 before we move on to part 2. In part 1, we looked at what a class model is, what they look like, why we use them. We looked at some fact-finding techniques, the key components of a class, and we produced the first draft of our example class model, which you can see on the screen. In part 2, we're going to consider associations and business rules. In our discussion of business rules, we'll look at multiplicity, including what are known as many-to-many associations. We will also consider the importance of enforcing business rules. We will develop our example class model further to make it look like this one. So let's get started. An association between classes exists when there is a business connection or relationship between the classes. There's a relationship between customers and orders because customers place orders and orders are placed by customers. A line is used to link the two associated classes together. In the example on the screen, you can see that a line has been added between the customer class and the order class to indicate there is an association between these two classes. You can annotate the line to explain the meaning of the association, although this is optional and is not common. In this example, we've annotated the line to specify that customers place orders and that orders are placed by customers. You can also include the use of an arrow. This is also optional and can be used to add more meaning to the association. Let's look at another example. In this example, you can see we've used annotation to specify that an order includes products and that products are listed in orders. Let's put these two examples together. Putting these examples together, our sample class model now looks like this. As we mentioned earlier, annotating the lines with text and arrows is not common, so we will not be using it anymore in the course. So now we understand the concepts of associations. It's time to move on to consider the business rules that govern these associations. Business rules specify the number of classes that can be involved in an association. These are known as multiplicities, and this is where things start to get a bit tricky, as these can be quite complex. Remember, one of the aims of your fact-finding activities is to determine the business rules that exist in the organizations or the systems being investigated. To do this, you need to examine each class in turn and, working with your stakeholders, determine how many instances of an associated class are associated with each instance of the class in question. Let's use our example model to explore this further. In our example class model, we know there's an association between customers and orders because of the line between them. We now need to add information about the numbers involved in this association. We need to specify the number of orders that can be associated with each customer and the number of customers that can be associated with each order. In this example, we've added the number 1 on the association line next to the customer class. This indicates that each order is associated with one customer. Notice the placing of the number next to the customer class. Understanding this placement is critical to understanding class models. In business terms, the multiplicity specified here can be expressed in a number of different ways, all meaning the same thing. We could say each order is associated with one customer, or each order is placed by one customer, or each order is placed by one and only one customer, or even each order must be associated with one and only one customer. Although it's possible to have an exact number, as in this example, this is quite rare. It is much more common to see a range of numbers. In this somewhat unrealistic example, we can see that a range of numbers has been added to the line next to the order class. This specifies how many orders can be associated with each customer. This specifies that a minimum of 1 order and a maximum of 10 orders can be associated with each customer. In business terms, this can be expressed in a number of ways. Each customer is associated with between 1 and 10 orders. Each customer can place between 1 and 10 orders. Each customer must place between 1 and 10 orders. However, as we have said, this is somewhat unrealistic, as it would be rare for any organization to put an upper limit on the orders that a customer can place. In this example, the asterisk or wildcard has been used to indicate the association has no upper limit, which would be a much more realistic scenario. This association can be expressed in the following ways. Each customer is associated with at least 1 order. Each customer can place at least 1 order. Each customer can place many orders, or each customer must be associated with at least 1 order. In the example so far, we've used the word must several times. This is because of the use of the number 1 in the association. This specifies there must be at least 1 associated class. Understanding the mandatory nature of the association indicated by using the number 1 is key to successful data modeling. This is because databases are often designed and developed in such a way as they will enforce the business rules specified in the model. Let's examine the business rules in this example. Firstly, let's take the 1 asterisk against the order class. This specifies that each customer must be associated with at least 1 order. Saying that in a slightly different way, there must be at least 1 order for each customer. If a database was built to enforce this rule, it would not be possible to capture or record the details of a customer without a matching or associated order. As soon as an attempt is made to save customer details, a system based on these rules would request the details of an order. Now let's examine the one against the customer class. The one against the customer class specifies that each order must be associated with exactly one customer. If a database was built to enforce this rule, it would not be possible to capture or record the details of an order unless it was matched to an associated customer. Let's make one slight alteration to this. Notice that we have now used 1:1 instead of just 1 to indicate the number of customers associated with each order. This specifies that both the minimum number and the maximum number are both 1. Using just 1 on its own is acceptable, but 1:1 like this is more precise. Now let's turn our attention to optionality. As we mentioned earlier, the business rules on this model specify or state that the customer must be associated with at least one order. But what if an organization wants to capture customer details before they've placed any orders? Perhaps the organization captures details of potential customers. Perhaps customers need to be approved and added to the system before they can place orders. As it stands, our model would not support these scenarios. So what do we need to do? In this example, you can see we've used a 0 to indicate that a customer may be associated with no orders at all. The business rule now states that a customer may be associated with many orders or none at all. This is sometimes known as optionality because customer details can be captured without a matching order. We're now going to turn our attention to many associations, which can get a bit more complex. This may be a good point to recap what we've covered so far before moving on. Replay the video if you need to confirm you're clear on everything so far, and continue when you are ready. Let's start by looking at an example. Here you can see that, firstly, each order must be associated with at least one product with no upper limit. And secondly, a product can appear on many orders or none at all. As you can see, each side of the association is adorned with an asterisk. This is known as a many-to-many association. Whenever you see this type of association, you need to examine it carefully. From a technical database design perspective, there's a need to use what is known as a linking table in the database. But that's the technical development domain, which, although interesting and important, is not the business analysis domain. From a business analysis perspective, although it's possible that this reflects the business situation, a true many-to-many association is extremely rare. It's much more likely that something's been missed. So when a business analyst comes across a model with a many-to-many association, they must investigate further to check that nothing has been missed. So what's been missed in this example? Examine existing documents, including forms and reports. In this case, we would look at examples of past orders or order forms. Consider each attribute in turn and confirm the class it belongs to. This would identify the need for a new class of order line. Here you can see we've added the order line class along with the relevant associations. Let's examine these associations and the business rules supporting them. The business rules associated with the new order class are as follows. Each order must have at least one order line, but there can be many. Each order line will be part of one and only one order. Each order line can have one and only one product. Each product may be on many order lines or none at all. Notice also that we've updated the model with additional attributes and operations. For the order class, we have attributes of order ID, date order placed, order value, and delivery status. The operations of the order class are capture order details, update delivery status, allocate product to order, and calculate order value. For the new order line class, we have attributes for product code, quantity, order price, and line total, with the operations being calculate line total. Finally, for the product class, we have attributes for product code, description, and price, with the following operations: capture product details, update product price, and delete product. Please note that the attribute of price in the product class is not the same attribute as order price in the order class. The former records the current price of the product and will change over time as prices change. The latter records the price at the time it was ordered and should not change over time. We can also see that the attributes of quantity, order price, and line total are unique to the order line class and do not appear in any other class. However, product code is also an attribute of the product class. This could be a potential problem, as product code seems to be an attribute of two classes, the product class and the order line class. It could be a problem because the rules of class modeling state that an attribute can only belong to one class. This brings us to the concept of keys, which will resolve this potential issue, but these are the subject of part 3. Before moving on to part 3, let's develop our model further to include the fact that orders are placed by customers. Here you can see the latest version of our example class model, including the customer class. The multiplicity on the association between the customer class and the order class specify that each order is placed by one customer and only one customer, but each customer can place many orders or none at all. And this completes part 2 of our course. Before moving on to part 3, let's do a quick recap of part 2. In part 2, we added associations and business rules to our example class model, now displayed on the screen. We discussed multiplicity, enforcing business rules, and many-to-many associations. We discussed the need to add an order line class. Make sure you're comfortable with this model and understand what it represents before moving on to part 3. If you're not comfortable, you can review the video to reinforce your understanding. In part 3, we're going to move on to look at the importance of keys and develop the model further with primary keys, foreign keys, and derived attributes. But for now, thank you for watching part 2. If you found this video useful and of benefit, it'd be great if you would please like and share it, and also subscribe to our channel. By doing this, you'll be helping us to develop the channel further and allow us to continue to produce and share more videos to benefit the business analysis community. We hope to see you in part 3, and goodbye for now.